So I've done my MIG welding video, so I figured it was time for me to do a TIG welding video. And I could talk for weeks and weeks and weeks about TIG welding, and I wouldn't cover everything. And I've done this video 5 times, and every time I do it, it ends up being 30-40 minutes long. And I want to cut this down to just the basic stuff and hopefully make it as short as possible, but give somebody some good tips and good tricks that will hopefully help them improve their TIG welding game. So all we're going to be doing today is some carbon steel, just regular carbon steel. We're going to weld this flat, so hopefully we get those decent arc shots, because the arc shots on that MIG welding video sucked. There was no arc shots at all. You couldn't see anything. But hopefully we'll capture enough, and I can go over enough stuff that it will give people enough tips and tricks that they can get a little bit better with their TIG welding. If you watch the MIG welding video, you know the first thing you got to do is clean your material. If you clean your TIG welding is 10 times worse. If you clean your material for 5 minutes to MIG weld it, you need to clean it for 10 to 15 minutes to TIG weld it. Once you're done your material, whatever wire you're using, if you're using carbon wire and you're doing some carbon steel work, it's going to have a coating on it that's called silica. Take you some Scotch-Brite, and you can take and rub that coating off, and it will help you keep that silica out of your weld. Now the silica burns off, and it's not really supposed to affect your weld a whole lot, but the fact that it is trash. If you boil it down to the very basics of it, it is a trash once it's introduced into that weld. And depending on how you're welding and your speed and a bunch of other stuff, you can get little droplets of silica in your bead. So clean it. Same thing with your tungsten. If your tungsten is not really sharp, really shiny, take your time, clean that tip, because if it's trashy, it can produce some contaminants inside your weld. So clean everything as clean as you can get it. TIG welding is completely different than any sort of welding you'll do. You can technically weld 2 pieces of metal together without any filler wire, without anything, because the heat and the puddle will fuse everything together if your heat is right and your speed that you're moving is correct and you have enough gas flow. If you try to make a T-joint and it's some pretty thick material that would handle the heat and you just wanted to fuse it together, you could do that, but when you're done, your top and your bottom, it's going to have a little wavy line that's indented, and what that's called undercut. And depending on if you're trying to do some shop work or maybe go pass a test and get a job somewhere, if they have a QC, he's going to look at that, and depending on the code or how picky the QC is, he's going to deny it, and it's going to be a cut out or a throwaway or you're fired or you didn't get the job type situation. So what you want to do, and what we're going to do, is we're going to add some filler material. And you need to figure out your machine, but that's completely on you because I don't know what machine you have. I've got an Everlast 200 DV, and it's an AC/DC machine, but we got it set on DC for doing the carbon steel. AC is aluminum, but like I say, I'm not going to get into aluminum or stainless or none of that. Got it set on DC. I've got it set somewhere around 200 amps, I think, but I'm going to use a foot pedal because personally in this fabrication style stuff, I really like to use the foot pedal because I have a little bit more control over my heat and then my starts and stops. So I can control how much heat's actually going into that puddle without going over there and adjust the machine. So figure out if you got scratch start, if that's what you like, if you like foot pedal, if you like the little finger pedal, if you like touch start, whatever you like, figure that out, what works best for you. So the way we're going to do it, and we're not going to use a pulse setting. If your machine has a pulse setting, some people like the pulse. It's a whole different line of stuff. You have a pulse setting, and then how fast it pulses, how long the pulse will stay on and how long it will stay off. All kind of other settings in there. Most machines have a pre-flow and a post-flow. That's all on you to figure out. You just got to figure out your machine. So we're going to take this, we're going to get our puddle going, we're going to dab some wire, we're going to pull the wire back just slightly, move forward, dab some more, pull out just slightly, and try to move forward the exact amount each time. It's a consistency game. I don't care if you're stick welding, if you're TIG welding, if you're MIG welding, if any kind of welding that you're doing, it's a consistency game. How consistent can you make your body do that same movement over and over and over? And a small story You make it real fast. But one of the first really big jobs I was on was a DuPont ethanol plant. And it was a cellulose ethanol plant. It was some kind of experimental thing. In fact, they never even got it going. The plant's actually up for sale right now, and they're going to convert it back to an LNG. But I was pretty rough on stainless steel when I got there, on Schedule 10 stainless steel. I thought I was pretty decent, but I wasn't up to like really good QC type quality. I'd done a lot of paper mill stuff where it was kind of more slam and jam stuff, and I really needed to work on my end game, my caps, how good my caps look. I worked on it every day as hard as I could for about 4 months. Had a QC walk up to me one morning after the morning meeting. He's like, "Hey, I need to talk to you." He said, "I got a picture of one of your welds in my office." And my heart dropped. I thought for sure I was getting walked to the gate. And because they used to fuss at me all the time about my caps not looking super consistent. And they would be really straight and then kind of weavy a little bit, or maybe it was really straight and then one side would go out just a hair more than the other and come back in. And sometimes I would file that edge off, and then they didn't like the file marks because technically that's undercut because you're digging into your material. So my heart dropped. I just knew I was headed to the gate. And he said, I said, "Well, what is it? Can I fix it? Tell me what I need to do." And he started laughing. He said, "No." He said, "The head QC for DuPont came down. He seen one of your welds over there by the reactor tire. He took a picture of it and said it was the nicest weld that he has seen on this entire job site." And I had worked month after month on how consistent I could keep my arm moving over, back and forth each time to get the most consistent weld I could get. I had studied everything I could on getting consistent, how far my tungsten stuck out, my gas flow, the whole 9 yards. And then I worked on my arm. How consistent could I get that thing to move back and forth to get that weave look that I was looking for each time. So practice your consistency. Same thing with feeding wire. Grab you some wire and then practice feeding that wire. Sit at your kitchen table eating, sit at your couch watching TV, driving down the road. Figure out a time of day that you can practice feeding that wire until you can figure out what works best for you, whether it's like this or like that, or whether you can do something weird. Whatever works for you. If it works, it works. Once you get all that figured out, then it's just like MIG welding. It's a hood game. You put on your hood and you just keep doing it until you figure out what's working, and then just you mold that. Whatever's working for you, you mold that into perfection, or as perfect as you can get to perfection. We're going to fire up on this because we're already about 8 minutes long. Hopefully we'll get some really good arc shots. I'm going to try to slow down and speed up as we do this to show you how speed will affect your weld. Everybody that TIG welds, they see these welds on Instagram, these stainless steel manifolds, all this really nice blue and gold and purple looking welds on it. And what that boils down to is it's a heat thing. It's how much heat that they were able to keep out or to put in to that material. I've welded some heavy wall stainless before, and I've actually capped it and had enough argon flow, was moving hot enough, and was still. So I don't. The GoPro cut off. I don't know what happened, and it's never done that before. But it's a good time. If you've watched this video this far, go type the word TIG, or go type the word TIG welding. I don't care. Whatever you do, just put TIG in there, and I'll pick one person within 24 hours, give them 5 free inches into the giveaway Honda. And September the 25th, y'all know the whole deal. Let's get back to this TIG welding thing. So the color, it comes down from heat. And the heat is how many amps, how fast you're moving, and how much argon flow. So play around with that, figure out what works best for you, and you can get some really nice welds. So I'm going to go turn this machine on. I'm going to crank this argon on up, and we're going to lay some beads down. let's take a quick look at this. We'll go over it real fast, and I know this video is getting crazy long, so we're just going to try to go over it real fast and then we'll cut it off. So the first video I tried to cover on the on the welds kind of didn't come out real good. We had some really bad lighting, so we're going to try this again. And the more and more I sat out there watching this footage, I got super pissed off on how bad these welds looked. So I had to push everything out of the way, get real comfortable, and try another one. So I did this bottom one, and you can see it's night and day difference. One thing I forgot to cover was making sure you're comfortable. If you're not really comfortable, you're not going to have a really good weld. I was trying to work around the GoPro, trying to make sure we got decent arc shots, which looking at the footage we didn't. You still can't see the puddle. I guess this tripod I have is way too tall, and it sets up too high. I'm going to have to figure out something for better arc shots. But me trying to work around the GoPro, trying to hope we were getting decent footage, made me uncomfortable in the position that I was at. So you can see how that affected the weld. It started off a little decent, and then right off the bat we had a bloop, and then I kind of got a decent rhythm, and then we got another bloop. And even the whole time I was going, you can see the inconsistencies in the weld. And you can even see the weld itself tries to arc up a little bit, just because my wrist was constantly trying to turn, making sure my hand wasn't getting in the way of the GoPro. So when I pushed all this aside, and I pushed this plate up high, and I got my hands up here, and I was real comfortable, you can see it's a really nice straight weld, and it's got super good consistency to it. There is a couple mess ups. Start off with the first 3 or 4 little dabs are pretty close, but then it gets a nice little jab. I do got that jab there is a little tighter than the rest, but after that it gets pretty decent consistency. I'd rate that one at somewhere around an 8, and those are probably somewhere around a 6. Now, one thing to notice is I welded these back to back, and if you look at the top, this color outside of the weld and this color here is your heat affected zone. That kind of gets into some QC type knowledge and QC type topic, and I'm not going to cover a whole lot of that, but there's a ton of knowledge on Google if you want to try to look into that. But since I welded these back to back, the material was already hot, plus I turned it up about 15 amps, and you can see how that heat affected it. So if you were welding something and you were concerned about how much heat you were putting into it, you can see that the second time I welded it, I had 10 times more heat than what I had up here. But since I want to make this video as short as possible, I'm going to leave it there. Clean your material, learn your machine, practice your butt off, get really, really comfortable when you're welding, and then it's just a hood game, and you'll eventually get as good as you want to get. You'll get as good as you push yourself. If you push yourself to be perfection, you'll get really, really close to perfection. So, it's crazy late. My mouth's drying out again. I got to run inside, grab something to eat, grab something to drink, try to catch a couple hours of sleep. I'm going to end this here. We'll pick a person, give them some 5 free entries in 24 hours. So best of luck to whoever wins. And that's going to be it. So until next time.